Hello. This video will show you how to use SiteMatcher. SiteMatcher is a web server for structure-based drug design using protein-ligand interaction patterns. Let's begin. First, click the red button to upload your protein file. You can prepare the input files by splitting an X-ray co-crystal structure of a protein-ligand complex. Or you can prepare the input files from molecular docking. SiteMatcher can accept SDF, PDB, MOL and MOL2 formats. The preferred file format is PDB. You need to prepare the input files well, add hydrogen, add missing residues, assign the bond types for ligands, etc., before feeding them to SiteMatcher. Since SiteMatcher needs to extract protein residue information, the input protein file should contain amino acid information of each residue. Besides, please check the spatial relationship between the protein and ligand files to make sure that the ligand is positioned within the protein's pocket. In this example, we use the 3s4q file, and its structure appears on the right. Next, upload the ligand file. Now we can start. Select the files and choose the working mode. Here, we use the replace mode. Then click Submit. It will display all potential replaceable substructures. If you click an index, you can view its 3D structure on the right. The atoms to be replaced are highlighted in red. In this example, we choose the second option and submit it to step 3. On this page, you can select protein binding residues. SiteMatcher already recommends suitable sites based on the vector from the previous step. We strongly recommend manually selecting the binding sites where you want the interactions to occur. Now let's start step 4. Here, you can set restrictions on the fragments. Click Select, and the parameters will appear on the right. Physicochemical properties. Here you can restrict results based on fragment level properties, such as fragment weight, TPSA, ensuring only fragments within the desired range are kept. Heteroatom. This filter lets you control whether fragments contain certain heteroatoms, such as oxygen, nitrogen, sulfur, or halogens, which are often crucial for activity. Ring_composition. You can constrain the types of ring systems present in fragments, aromatic rings, heterocycles, so that only fragments with the right backbone are kept. Functional group. This option restricts which functional groups, like hydroxyl, carboxyl, must or must not appear in the designed molecules. The other parameter option allows you to set custom, unique constraints. If there are binding sites that must be satisfied, you can set them as mandatory binding sites. SiteMatcher will then ensure that all search results strictly meet the binding sites you specified. If you choose one site, the designed ligands must include that interaction. If you choose 2, only designed ligands containing both interactions will be kept. In this example, we select MET109 and click Submit. Please wait about 1 to 2 minutes while SiteMatcher searches for possible results. The results are shown in a table with binding score, target site, helper PDB site, and SiteSim. Binding score is the predicted score showing how well the designed ligand binds to the protein. Target site is the specific protein site where the ligand makes contact. Helper PDB site tells us which PDB entry the fragment originally came from. And SiteSim is the similarity score between that helper site and the target site. We can see that the SiteSim score for the first result is 1. To check the 3D structures, click 3D View. If you don't want to see the original ligand with red highlights, click the blue button to hide it. By comparing the target site with the helper PDB site, we find that both originate from the backbone, which explains why the score is 1. All results here include MET 109. To download structures, click Download for individual results, or scroll down to download all results as SDF or SVG. Next, let's go back to step 1. This time, choose the Grow mode. We upload the 5FNQ file as an example. We select the fourth option and submit it to step 3. We use the protein site recommended by SiteMatcher as the target site, then continue to step 4. This time, we choose 2 mandatory binding sites, TYR334 aromatic and TYR334 donor, and click Submit. We can see that the SiteSim score of the first result is 1. By examining the target site and the helper PDB site, we find that both interactions arise from the TYR side chain, one from its aromatic group and the other from its donor group. That's how to use SiteMatcher. If you have any questions, please feel free to contact us. We'll be happy to help.